We're here today to help you review the Lewis dot structures in VSEPR.
The first step is to create a Lewis or dot structure.
Lewis dot structures are two-dimensional structures of molecules or ions which depict the electron bonding in the molecule or ion.
To do this, you must first determine the total number of valence electrons using the periodic table, and then determine the central atom, and this will usually be the first element written in the formula, and will always be the least electronegative.
Step 3. Draw these atoms using their abbreviations found on the periodic table and connect the atoms with single bonds, represented as a single line. Step 4. Complete the octet on the outer atoms, except for exceptions, using the remaining electrons. Step 6. If any atom is unsatisfied, begin using multiple bonds, represented as multiple lines. Step 7. Check all octets and also the total number of valence electrons.
Terms. Resonance is when one Lewis dot structure cannot properly depict the bonding in a molecule.
Octet sections are hydrogen and helium have 2 valence electrons, boron and beryllium can have 8 or less, and phosphorus, sulfur, and xenon can have 8 or more.
VSEPR stands for valence shell electron pair repulsion.
To make a VSEPR, you must draw a Lewis dot structure, determine the number of electron domains, number of atoms, determine the arrangement of groups, do this using the chart provided by Mr. Howard, determine the number of bonding domains, single, double, etc., bonds drawn as lines on the Lewis dot structure. Based on this, determine the molecular shape found on the chart.
Electron domains are 2, 3, and 4. The arrangement of groups is linear, trigonal, planar, and tetrahedral.
Based on the electron domains, the arrangement of groups, and the bonding domains, these shapes can be linear, bent, trigonal planar, trigonal pyramidal, or tetrahedral. Now, pause your video and try these problems using what you have just reviewed about the Lewis dot structure in VSEPR. So, the Lewis dot for H2O, or water. We start by putting oxygen as the central atom. Hydrogen. Since there are 2 hydrogens, they'll be on either side. Draw single bonds and complete the octet. Since hydrogen is an exception, it is satisfied with 1 electron single bond. And that is the Lewis dot structure for water, or H2O. PCl5. Cl is also an exception, or P is also an exception, phosphorus. So start with the central atom. And then add the 5 Cls and connect with single bonds. Now we complete the octet on the Cl. Since phosphorus is an exception, it has more than 4 bonding domains. It accepts more than the normal amount of electrons. Therefore, it has 5 single bonds.
The next one is for HBRO. HBRO contains the exception bromine, and So you first find the valence electrons, and you'll find that it has. First, you draw the central atom, which is oxygen. Then you'll draw the hydrogen and the bromine, and then draw single bonds connecting each. Then you'll complete the octet for each, which is oxygen. Hydrogen is an exception, so it only uses 2, and then you'll complete it for bromine as well. The next one is for SO2. This one contains a double bond. So first you will draw your central atom sulfur. Then you will draw the 2 hydrogens, oxygens. You'll draw a single bond to each. And we have too many valence electrons. It contains 8. We'll complete the octet first, actually.